As you can see by having studied and looked at the Gremlin language, it's a powerful and expressive and general-purpose language for defining graph traversals. From having studied and seen many examples of the Gremlin language, you already know that it's a powerful, expressive, and general-purpose language for defining graph traversals. You can do a lot with it, and technically it is a Turing-complete language. The graphs that you are building are going to be within a particular domain. And as you have seen here throughout this series, all of our examples have been dealing with film. However, all of the graphs in your domain will be located within the business that you're serving. Therefore, it'll be a really good idea to customize the language that you use to talk about the graph traversals in your domain. This is a topic that shows up in many places other than just graphs. Domain-specific languages are often a good idea. You can extend Gremlin to build your own custom DSLs on top of it so that you can describe traversals in a much more expressive and compact way. Now, I'm not going to show you how to implement a Gremlin DSL. That's a slightly bigger topic. But here, we're going to introduce the idea and show you the kind of things that you would do with a domain-specific traversal. And we hope that you see the value in DSLs and see that they're a useful tool to implement and worth pursuing. Now, let's take a look at a hypothetical DSL that we could define with the KillrVideo movie schema. This maps onto the kinds of traversals that we have been doing in the other examples throughout this series. For example, we might define a step that will look for all of the vertices called movie, label them M, and then return their values at the end. In the middle, there will be other kinds of steps that we could put there in order to do different things. Those steps could be like with actor, where we will look for the movies with an actor with a particular name. We also could have something like with director or in category, where we might limit the movie vertices only those that appeared in a particular genre. Or we could constrain to look for movies with only a high rating, as seen with the with higher rating DSL step. Or we could constrain our movies to those with a higher rating, as seen with the step named with higher rating. Now, for each one of these that you can see here in the slide, those translate to a certain amount of native Gremlin code. We would rather not look at that native Gremlin code if we do not have to, so we would rather speak in terms of the domain. That ends up creating queries that are much easier to read and much more expressive. Now again, this isn't a full example of how to implement a DSL, but instead it shows us what to do with a DSL and what it would allow us to build. As always, before digging into our examples, let's take a look at the KillrVideo graph schema. We have users who know other users, and those users rate movies. There are other people in the graph, like actors, directors, and screenwriters who have participated in the movie, and these movies belong to genres. In the first example here, what we see is that we would like movies with the actor Tom Hanks. By using a DSL, we see that this traversal reads almost like English. The second traversal on this example is showing what the equivalent Gremlin would look like. Here, we're going to the movie vertices, labeling them as M, traversing through the out actor edge, and finding the person named Tom Hanks. Then we select the movie vertices and look at their titles. As you can see here, we're getting results like The Da Vinci Code, Sleepless in Seattle, You've Got Mail, Forrest Gump, and The Green Mile. As you can see with these two traversals, it's much easier to say and read movies with actor Tom Hanks by using a DSL. On this next example, what we're saying here is that we would like to find movies with actor Tom Hanks that are in the drama category. By using a DSL, as you can see, this first version communicates pretty well what the traversal is doing. The subsequent Gremlin traversal on this slide shows you how to write the full query. And if you have studied the basics of Gremlin, you might not find the second example to be too bad. But if you are not a practiced Gremlin developer, you might rather write the top instead of the second example. We will keep adding to this query to show you how to build up a great DSL and how awesome it can be to use one. In this next example, the top query which uses a DSL is looking for movies that have Tom Hanks in the drama genre, but then we say we only want those movies to have a rating higher than 7.5. Compare this use of a DSL in this first example to the full query, which is listed below. In this second query, we label all of the movie vertices as M, and then we walk out the actor edges to those with the name Tom Hanks. We select M to get back to the movies, and we walk out the belongs edges to get to the drama genre. Lastly, we select all of the movie vertices so that we can only keep the movies in the traversal stream if their average rating is greater than 7.5. Then we select M, look at the movies by title, and we see that we satisfy all of those constraints. We find Forrest Gump and The Green Mile. Finally, we're going to put together the other steps that we laid out in our hypothetical DSL. We're going to look for movies with actor Tom Hanks and the actor Gary Sinise. Then, we also want to look for those movies with the director Robert Zemeckis in the drama category, but we also want to find those movies with a rating higher than 7.5. And this also ends up being Forrest Gump. You can see the equivalent traversal on the bottom part of the code. And again, it isn't using any sophisticated constructs, but it does end up being a lot of code. In my opinion, I would rather be looking at and using something simpler, like a DSL. And that is really what DSLs are all about. They don't make the impossible possible. They just build up pieces of a lower level language to make a more flexible and powerful way to express your queries. Now, domain experts who do not know Gremlin will be able to read a well-crafted DSL. And if you have designed the DSL well, everyone who has to build code with the DSL will be a little bit more productive. It is also easier to validate code written in a DSL. Since the language is domain-specific, it'll be easier to see that it is expressing the thing that we intend for it to express. So as your traversals get more complex and you begin to see patterns emerge in your domain, this is a topic worth exploring further.